My task in this talk is to tell you a bit of the future solution for these problems in case we're too downhearted by the thought of the problem that's facing us. This is the future for us. From estimates of yield loss and distribution of nematodes, those two species that you've heard about are probably costing the wheat industry $123 million a year. This could be saved if we were to grow resistant varieties as well as tolerant. I think you've heard about Gregory and Wiley as tolerant varieties. I'm going to concentrate on resistance. We have sources of resistance for plant breeding from GS50A, which is a selection from Gacha, and wheat land races from West Asia and North Africa region. Some of the older ones of us here would know that as the Middle East of the world. And resistance to both species can be found in synthetic hexaploid wheats and possibly some Iranian landrace wheats. The GRDC has just funded us for a major project to get these resistances into parental material so we can make this available to wheat breeding companies. So we're crossing these resistant lines into tolerant lines like Gregory and Wiley. To date, thanks to past efforts of our group and wheat breeders, we've got resistance to GS50A in a background that is suitable for wheat breeding companies to be crossing that already. And we're very actively working now on getting these other resistances combined together into suitable parental material for breeding. A simple definition of tolerance is a wheat variety that grows and yields well in highly nematode infested soil. So a variety that can do that is tolerant, and I think we saw from Stephen's presentation just what is tolerant, what's moderately tolerant, how long's a piece of string. And then we can see the other end of intolerance, and we've heard a fair bit today about Strzelecki, but one of the most intolerant varieties has been Gacha, and in some past experiments that could have lost up to 70% of its yield on a highly nematode infested site. Now in contrast, a resistant wheat is one that retards nematode multiplication in its roots. So we talk about one that has low numbers of nematodes building up in the roots as resistant, but one that builds up quite a lot is known as susceptible. So let's talk about how they build up. Kirsty alluded to this. They complete their life cycle about every month under favourable conditions. This is to be contrasted with cereal cyst nematode, which has only one life cycle in the whole growing season. But the root-lesion nematodes build up, and that once again is an exponential build-up, and it'll depend on environmental conditions. The two sorts of well-watered seasons we've had the last couple of years, they probably contribute to quite a high build-up on susceptible varieties in the field. And resistant varieties prevent this build-up. So let's see what the advantages might be if we had resistance in our varieties. We'd have fewer nematodes to harm the root system of the current crop as the season advances. I think Stephen nicely showed that even a tolerant variety, what we think is tolerant now, if you have a season where the nematodes really build up, it may suffer some yield loss. The other advantage is that after you've grown that crop, there'll be fewer nematodes remaining in the soil. So that's a point. And they are then fewer nematodes to attack the next wheat crop. And there'll be fewer nematodes to attack other susceptible rotational crops. For example, we heard from earlier speakers, barley, chickpea, mung bean, soybean. That's for Pratylenchus thornei. With Pratylenchus neglectus, sorghum, some varieties of sorghum appear to be a host of that, so that's worthwhile remembering. This is some data from our site at Formartin, and we heard earlier people talking about the tolerance of Wiley and Strzelecki. Where that information comes from is this site, and we've been running that for many years. We have 2 times of planting there, and we compare the yield of current varieties and prospective varieties that are submitted under NVT. And a technique is to have a rotation where we're rotating with sorghum, but we're testing our, and Longfellow, and we're testing our varieties following a uniform wheat crop, which is used to build the nematodes up. So, coming into 2011, this was the population in the soil profile. Following, we used Kennedy as our variety to build these nematodes up from the year before. And you can see that this distribution here is quite high in the topsoil, but still even right down here at, what's this, the 60 to 90 centimetre interval, we've got above this 2000 threshold, which we're using for convenience. So it's a whole profile full of damaging populations, but particularly high when those plants are young. And so this is the type of result we got from this year. There are like 100 or more entries in this trial, but I've just picked out some to illustrate some points. This is the intolerant Strzelecki, which we've referred to a bit today, and you can see what yield we got. This was the same trial that Kirsty referred to that was planted on the 25th of June. Circumstances we used there was a full profile of moisture. We apply 100 kilograms of N as urea before planting, and we apply starter Z at planting. So you can see some of these other varieties. Baxter's down a bit to where we might usually expect it, but say Lang and Kennedy, and then we've got our tolerant varieties, Sunvale, Gregory, Wiley. This level of tolerance we have now because of the efforts of past wheat breeding activities, and in the past, in the north here, we've targeted tolerance pretty much to Pratylenchus thornei. And what I wanted to show you here, though, these are some fixed lines that have a background of Jan's Cunningham, in which the resistance of GS50A has been back-crossed into that. And you can see the kick in yield here that comes about in the current season. A lot of time people talk about resistance as something for the help you in future crops, but we've found this before on this side, and here it is in a high yielding year that these varieties, and probably that germplasm Jan's Cunningham, it's a good background, but there are possibly better head-to-head varieties out there now. And we're turning in here like 5 3/4 tonnes a hectare. And remember that this is wheat on wheat. We're not taking the advantage of a rotation to get the nematodes low. We've deliberately built them up to, so we can really challenge the tolerance, and clearly resistance is contributing to that. So what does resistance mean for residual nematode populations? This is some past work which we did, and here these particular varieties have been recropped 3 years in a row on the same plots. Sonica had some moderate tolerance, but you can see it's quite susceptible. Potan is a Mexican variety which is the source of tolerance we identified some years ago, and is in Gregory. Yeah, hang on. Yeah, it's in Gregory. And Gadget is this intolerant variety. Now you can see it's probably here, its own intolerance is limiting the build-up in nematodes, because if we test that for resistance under glasshouse conditions, where we supply a high level of nutrition and continuous water, you'll find that Gacha will build up nematodes quite a deal higher than that. This is GS50A, and you can see that it's, even though it's derived from Gacha, but particularly so compared with Seneca, a commercial variety, it's leaving far fewer nematodes in the soil. But you can still see that's higher than in continuous fallow, and I think I referred to that before. You can see how with fallow the nematodes are surviving down the subsoil better than they are up in the top here. So if we had resistant wheat varieties to grow, this could be the pattern we might, this could be the pattern we might have. Now, this is some work also from our site at Formartin. This is in crop rotational work which is led by Kirsty Owen, and I've just taken some of the data from that work to show here again in a different experiment 1 year of GS50A compared with 1 year of Kennedy, and these are the populations that are in the soil. Was that taken after harvest, Kirsty, or before planting? Pre-planting. It was pre-planting. So you can see here there's a slightly different pattern with an enormous population in the subsoil in that particular year. And when we crop with an intolerant variety after this population in the soil from resistance, or this population from a susceptible wheat, we're turning in this difference in either biomass. This is the dry matter. Unfortunately, flooding prevented us getting grainier there, but you can see the enormous difference. Just to change tack a little bit, I've been trying to illustrate to you with GS50A alone, okay, thanks John, that what resistance can do for us. We've been looking for other sources of resistance, and in glasshouse studies we've screened these numbers of accessions from this type of material: Aegilops tausii, which I'll mention a bit later, durums, synthetic hexaploid weeds, Wana landraces and Iranian landraces. So we've screened that number, and we've found this number that had fewer nematodes than P. thornei, and out of those we've selected some which consistently produce significantly lower numbers than GS50A to continue with. So we've mentioned GS50A quite a bit, and two of the Wana landraces which we favour in our work, and we're using this now for parent building, a Morocco 426 and a RAP 43, and this Iranian landrace here, AUS 28451. I just mentioned synthetic hexaploid wheat lines. We're working with 5 of these, and the synthetic hexaploid is produced by crossing durum wheat with goat grass. This is endemic in like from Turkey through to Afghanistan, that part of the world, and you can see the change in the head. It's a complicated breeding technique to get these to hybridise. We don't do it ourselves, but we're taking advantage from international people who've done it. Here's a durum head. You can see a wispy tausii head here, and immediately after this hybridisation is done, the synthetic hexaploid looks like a breadwheat head. And as I mentioned, there are 4 Iranian landraces which also might bring resistance to both thornei and neglectus. And this will have some advantages in parent building and ultimately in wheat breeding. So just a call to action then. Continue to grow nematode tolerant varieties. I haven't talk much about this, but if you go to planting guides, the one put out by DEEDI and NVT online, you'll be able to see not only the tolerance of varieties, but differences in partial resistance. And there might be some advantage in choosing among current varieties in that regard. I could warn you though, with partial resistance, it can also be environmental dependent. So one that looks better under certain circumstances may not turn out that way under other circumstances. These resistances are polygenic, and what we're doing in this new program is trying to make sure we get a lot of the genes in there, and then we believe we'll have greater stability independent of the environment. And in the future, we hope in those guides we'll be able to see new varieties with superior levels of resistance to both nematode species. And that'll have obvious advantages because you won't have to be so particular about knowing exactly what species you're dealing with. Although, as previous speakers have said, thornei is our biggest problem in the north. Thank you, John.